So in this video today, we're going to go over basic probability. Our objectives today are to determine what is probability, and then also determine what are unions, intersections, and complements of sets of data. This is our warm-up for the day, so I'm not going to go over that right now, but that's what it was. So probability is finding the chance that a specific event is going to happen. So probabilities are written as fractions or decimals that are between 0 and 1, or percents between 0 and 100. So obviously if something's impossible, it's 0%, and as we move towards this continuum here of being 100% certain, that's when our probability goes up, right? So if we're halfway between impossible and certain, that's 50%, which would be 0.5, or 1/2, or again 50%. So the formula to find theoretical probability is the number of outcomes in the event, what you want to happen, over the number of outcomes in the sample space. That's the total number of possibilities. So other vocabulary that's key to probabilities is an event. It's a set of one or more outcomes in a probability experiment. Examples: rolling an odd number when a die is rolled, or sample space. It's the list of every possible outcome for a chance in an experiment. So sample space means what are you expecting to happen? What are the total number of things that could happen? The event is what did you want to happen? Okay, so that's why it says what do you want over the total number of possibilities here. Okay. So example 1 says, what is the sample space for flipping a coin and rolling a die? So it's one coin that you're talking about here, and it's one die that you're talking about. So if we were to talk about the actual coin, we could have heads or tails, right? But how many outcome could you have for your die? So you can have a 1 for heads or a 1 for tail, right? You could have 2 for heads, a 2 for tails, a 3 for heads, a 3 for tails, a 4 for head, a 4 for tails, right? Same way with 5, and then heads and tails 6, right? Because you have 1 through 6 sides on your die, right? So your possible outcomes here would be 12 different outcomes, because you could get heads with 1, 2, 3, 4, 5, 6 on the die, or tails with 1, 2, 3, 4, 5, or 6 on the die, right? So when we're talking about how many items would be in the sample space for 2 dice if they were rolled, then what would you say here? Go ahead and do this one. Come back to me when you're done. So on this one, wouldn't we have the first die 1, and then the second die 2, or first die 2, and then 3, and then 4, then 5, and then 6, right? So once again, I could have a 1, 1, a 1, 2. So how many outcomes are we going to get here? 1, 3, 1, 4, 1, 5. These would be commas, by the way, y'all. And 1, 6. So then how many do we have across? We have 6 across, right? And then how many do we have down? We have 6 down. So isn't that going to be 6 times 6? That means we're going to have 36 possible outcomes, right? So how many items would be in the sample space when 2 die are rolled? It would be 6 times 6, so that's 36. So for example 2, it says, for an experiment, each spinner below is spun once. The tree diagram shows the sample space. So basically, if with the first spinner, we could spin an A or a B, right? With the second spinner, we could spin L, M, or N, and with the third spinner, we could spin W, X, Y, or Z, okay? So notice here we have an A and a B, and then we've got our L, M, N, L, M, N, and then we've got our W, X, Y, and Z, right? So how many total outcomes would we have? We would look at the last column, right? So we've got 3 times 4, that's 12, right? Here again, we've got 3 times 4, that's 12. So for the total outcomes, wouldn't that be 12 plus 12, which would be 24, exactly, okay? So on the next one, It says when spinning all three spinners, what is the probability that they point to the letters A, N, and Y? So when we look at A here, and then we have N, and then we have Y, that's just one outcome, isn't it? One outcome out of how many total outcomes? That would be 1 out of 24. Okay. Now, if we wanted to write this also as a percent, a decimal, or as a percent, we could do that as well. So if we divided 1 by 24, we would get 0.04. And then remember, to get the percent of that, we multiply that by 100. So that's also equal to 4%. Okay? All right, the next one says, what is the probability that a spinner points to the letters AMW, ANZ, or BNW? Okay, so this time we're going to do these in separate colors so you guys can see it. Okay. So we've got ANW, AMW, come on, pen, AMW, so that's one. And then we've got ANZ, that's another one. And then we've got BNW, so that's another one. So isn't that going to be 3 out of how many total? 3 out of 24. That reduces to be, 3 goes into 24 8 times. That's 1/8, right? So that's what it would be as a fraction. Then if we divide 1 by 8, that would be 0.125 as a decimal. And then if we turn that into a percent, that's going to be 12.5%. Now remember, what you do to get the percent is you multiply the decimal by 100, okay? So for the next part of today's lesson, we're going to talk about unions, intersections, and complements. So I want to talk about intersections first. Intersections are where two sets overlap. Okay, so I'm going to write overlap here. Okay, that's where they overlap. Those are and statements. Okay, so and the way I keep this straight is this looks like an N. Let me do it this way. This looks like an N, and this kind of looks like an N. Okay, so then we have a union. And a union is an or statement, okay? So I always memorize the and looks like an N and know that the union is the or statement. So when we're talking about the union, we're talking about when two sets are combined, okay? That's another way to think of it, okay? And then the complement is when something is not in a set. So anytime you have this, when it says something's not, that's when it's everything but, okay? So we could write that, everything but. Okay? All right, so now this first one says, use the sets above to answer the following. So we have a subset A, which is 1, 2, 3, 6, 7, 9. A subset B, which is 2, 4, 6, 7, 8. And then the set, which is 1 through 9, okay? So it says use the sets above to answer the following questions. So what is the union, or the intersection, sorry, what is the intersection of A and B? Okay, so this is an and statement. So what is the intersection of A and B? So where do they overlap? That's what we're asking ourselves. So 1 is not in both sets, but 2 is. So we're going to write, I'm going to create a bracket here. 2 is in both, right? 3 is not in both. 6 is in both. 7 is in both. And it looks like those are the only values that are in both sets, right? Because over here we have an 8, but we don't have an 8 over there. We have a 4 in the set in the right, but not a set in the right. The B set, but not in the A set. So the numbers 2, 6, and 7 are in both sets, okay? Now this next one is the union of A and B. So this is when we combine A and B. So what we don't want to do is we don't want to repeat anything more than once. So we're just going to look at what's in both. So we're going to go and we're going to move through these sets. And good for us, they're in consecutive order, right? So here we go again. So we've got our 1. So I'm going to put it here, 1. And then we've got 2 in both sets, right? And then we've got 3. And then we got 4 in this set. And then we don't have a 5, but we have a 6. And then we have 7 in both sets, right? And then we have 8 in the right set, and or in the B set, and 9 in the So the only value that's not here is 5. Did you guys notice that? So everything but 5 is in A and or B. Okay, that's what this means. And remember, again, this is an and statement, A and B, and this is A or B. Okay. So the next one says what's not in A. Okay, so what we want to do now is we want to go and look at the whole set and figure out what's not in A. So what I'm going to do is I'm going to strike out the 1, the 2, the 3, the 6, the 7, and the 9. So what is left in this set is 4, 5, and 8. So this is going to be 4, 5, and 8. Those are all the things that are not in set A. Now this last one says what is everything that's not in A or B, right? So up here we had what is in A or B. So what's not in A and the union of B. So that means we're looking for everything that's not here, okay? Not this one, because look at this is A and B. Everything's just not A and B. Okay, so it means everything is not 2, 6, or 7. See that? So now what we're going to do is we're going to look at our set again. And let's go through it, our whole set here, and let's figure out what's not 2, 6, or 7. So not 2, not 6, not 7, right? So that's everything else, okay? So I'm going to put this one below because I think it's going to be bigger, okay? So that means we got 1, 3, 4, 5, 8, and 9. Okay? So that's everything that was not in A and B, right? And we had A and B up here, so that's why we used it, okay? All right, so this next one has to do with Venn diagrams. So I want you guys to write this down on your paper. Venn diagrams are diagrams that show logical relationships between sets of data. That's what a Venn diagram is. So an example for it says a manager owns 3 local area card maintenance garages and was researching certifications of mechanics that worked for her company. Consider the Venn diagram. So the first thing it asks us here is how many mechanics worked for her company. So to find this, we're going to add up all the numbers. So we're going to add 4 and 1 and 2 and 2. So that would be 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Okay, so there's 18 total people that work in her company. Okay, so that's what we got first, 18. Then it says how many mechanics are certified by ASE to do work on brakes. So where's our brakes title? Right here, brakes. Okay, so what we're going to do is we're going to look at this whole circle right here for brakes, okay? This is our circle for brakes. So it's looking to me like 4 and 1 is 5 plus 2 is 7 plus 2 is another 9, right? So that's 9. Then it says how many mechanics are certified by ASE to do works on brakes and tune-ups. Okay, so remember from last, when we're talking about an and statement, that is an intersection. Okay, so now we want to look at brakes. That was what we had before was brakes, right? So now we're going to look at brakes and tune-ups. So down here's our tune-ups, okay? So what we want to know now is how many are in both sections, right? So we got our green right here, and we got our blue right here. Y'all see that? So those are the people we're looking at, where they overlap. So that's a total of 4 people, right, that do both, okay? Then it says how many mechanics are certified to do work on either AC or tune-ups, okay? So either AC or tune-ups. AC, where's AC? Oh, there's our AC. So let's do this in a different color up here. So either AC or tune-ups, okay? So when we look at this one, this is a little bit different because it's asking us for tune-ups down here and AC. So what we want to do is count the total number in both sets, okay? So this is going to be 1 plus 3, which is 4, 5, 6, 7, 8, 9, 10, 11. So we want everything that's in both circles based on what was given to us, right? So that's 11, okay? Then it says how many of the mechanics have their certification for brakes or AC repair, but not tune-ups, okay? So we want brakes or AC repair. So brakes is here and AC repair is there. So we're looking at everything that's in this circle, but not tune-ups, right? Wait, let me see. How many of the mechanics have the certification for brakes or AC repair, but not tune-ups? Okay, so brakes or AC repair. So we're going to count now the numbers that are up here. So we're counting brakes, AC repair, but we don't want these people right here. Why? Or if there was somebody in here, we wouldn't want them either, because we don't want the people that do tune-ups, okay? So now what we're going to count is the 4 plus the 1 plus the 3, so that's going to be 8. Everybody see that? Okay. So let me clean up this drawing up here so we don't get confused as we move through the next part. So then it says, what is the probability that a mechanic selected does brakes and tune-ups? So brakes and tune-ups, remember, what does and mean? It's an intersection, right? So here's our brakes. So down here's our tune-up. Sorry, brakes and tune-ups. So what is our intersection of these two? It's right here, okay? Now it's asking us for the probability, okay? So 2 plus 2 is 4. So we're going to do 4 over our total, which was 18. That reduces to be 2 over 9, doesn't it? Because both 4 and 18 are divisible by 2. And then when we do 2 divided by 9, if we ask for a decimal, it would be 0.22, my bad, 0.22, which then also translates to be, we multiply that by 100, 22%, right? 3 ways to answer the question, okay, when it comes to probabilities. Then it says, what is the probability the mechanic selected does not do AC repair or brakes? Okay, so doesn't do AC repair or brakes. Okay, so that means doesn't do AC repair or brakes. AC repair is here, brakes is there. So if it's everybody who doesn't do this stuff, so that means these are all the people that do brakes, and these are all the people that do AC, right? So what's the number there? Doesn't do, so we got this total number here, 3 and 3. Y'all see this 3 here and 3 here? So that's going to be 6 over 18, which reduces to be 1/3, which we all know is 0.33, or what? 33%. Okay?